Welcome, curious minds, to the deep dive. Ever feel like you're wading through just tons of information, trying to find that one clear signal?
Happens all the time.
Yeah. Well, today, we're diving into something really fascinating.
Hmm.
How do we bridge that gap between, our messy, fluid human language and the very structured world of computers? Especially when we're talking to these powerful AI models. It's really about getting what you mean across so the AI truly gets it.
It's a huge challenge, actually. More than just a challenge, maybe a fundamental problem in how we interact with AI right now. These large language models, LLMs, they're incredibly powerful, sure.
Right.
But you can almost think of them as like super sophisticated guessers. They predict what comes next. And
Right.
that's amazing, but without really clear instructions, their best guess can sometimes, well, it can go off the rails. You get vague answers, unpredictable stuff, sometimes unreliable.
So our mission today for this deep dive is kind of like finding a shortcut, a way to understand how to make these AI interactions work better.
Exactly. We want to show you the brilliant simplicity behind making AI really grasp your intentions, moving past just hoping it understands your prompt.
To giving it precise commands it can't misunderstand.
Precisely.
And we've got a great source for this. It's based on some really illuminating lecture notes called Understanding User Input Commands, Radio, Select, and Checkbox.
Ah, yes.
They're by Jae Choi, who's an associate professor at George Washington University, and also the principal investigator of the CAFA initiative, that's C-A-F-A, pronounced Kappa.
Right, like CAPA. And that whole CAPA protocol is really about bringing that needed structure and predictability to AI interactions.
So these three commands we're focusing on at Radio, at Vora, at Select,
Fab.
and at Checkbox. They're like the specific tools for the job.
You could say that, yeah, they're like precision tools. They help transform our requests, which might be a bit ambiguous if we just type them naturally, into clear, actionable, structured data that the AI agent can understand perfectly. It makes the whole thing much more reliable. Efficient, too. The AI isn't guessing anymore. It's working with clear instructions.
Okay, so let's really unpack that core problem first. Bridging this language gap.
Yeah.
You mentioned LLMs are probabilistic.
Yeah. They work on patterns, probabilities. What's the most likely next word?
So if you just give it a really open-ended prompt.
It's like asking a vague question, isn't it? You shouldn't be surprised if you get a vague answer back. Or maybe something completely off topic.
Like trying to give directions by just waving your hands vaguely.
Yeah, exactly like that. And that's where CAFA comes in, specifically with this concept called Symbolic Input Control.
Symbolic Input Control.
Here's the bridge we're talking about. Its main purpose really is to take the potentially infinite range of things a user could type.
Everything under the sun.
Pretty much. And funnel it down into a finite, predefined set of choices, symbolic choices.
Why is that so important?
Because it guarantees the AI agent gets the information in a format it's actually designed to handle. You need that predictability if you're building reliable applications. Absolutely essential.
So you're not just hoping the AI figures out your vague instructions.
No, you're actively guiding it, giving it exactly what it needs to work correctly.
Right. So if you're aiming for AI agents that are robust, predictable, you really need this kind of structured input.
You do.
Which brings us to that first tool you mentioned. The one for unambiguous choices, at Radio.
At Radio.
Yes, at Radio. Its basic function is pretty straightforward. It creates a list of radio buttons, like you see on websites all the time.
Okay.
But the key thing, its defining characteristic, is that selecting one option automatically deselects any other previously selected option within the same group.
So you have to pick just one.
Exactly. It forces a single unambiguous choice. Remember those old car radios? Push one button, the other one pops out?
Yeah. That's a great analogy. You can only tune into one station. Makes it super clear.
It does. So practically, in terms of designing an interface, when would you reach for at Radio?
Well, the guidance is to use at Radio when you have a small number of options, typically say 2 to 5.
Okay, just to you.
Yeah. And crucially, you want those options to be immediately visible to the user, right there on the screen.
Why is that important?
It reduces clicks, makes the interface feel faster, more transparent. All your choices are laid out. You don't have to click a drop-down to see them. It lowers the cognitive load,
Makes sense. Less thinking about how to answer, more thinking about the actual answer. So what does the command itself look like? How do you write it?
The syntax is pretty intuitive, actually. It's at Radio variable label options list at P.
Okay, break that down.
Sure. Variable is just where the user's choice gets stored, like R1 or year, something like that.
Got it.
The label is the text the user sees. The question or instruction, like, what year are you?
Right.
And options list, that's where the choices come from. It can be a list you type right there, separated by pipes, like option, option C. Or
Or it can refer to a parameter you've defined elsewhere, which holds the list. More flexible sometimes.
okay, so let's use that example from the notes. At
Right.
radio year, what year are you? Freshman, sophomore, junior, senior.
Right.
At radio.
Right.
So the user sees the question, what year are you?
Mm.
And then 4 radio buttons, freshman, sophomore, junior, senior. Click one, the others are off. Simple, clear.
Exactly. Very direct. But here's where it gets more powerful. Often, you don't just want the text sophomore.
Oh, to do something with that choice.
Precisely. Maybe you need to score it or use it in some logic or process it somehow. You might need to turn sophomore into the number 2.
Ah, okay. So how do you handle that mapping?
That's where another command comes in handy, at MAP, at maybe. This lets you convert that selected string into something else, something more functional for this system.
How does that work?
Well, first you'd probably define your list. You might use at set for that.
Yeah.
Like at set, your names, freshman, sophomore, junior, senior, at list.
That's the display text. Right. And then maybe at set yearnums, 1234, for the values you actually want to use internally.
Okay, names and numbers.
Then, after the user clicks a radio button, let's say they chose sophomore, which is stored in the year variable. You'd use at map at radio year, at mampo, at year name, at yearnums, at appyable.
Wow. Okay, so that looks up the chosen value sophomore in the first list, at year names at A, and finds the corresponding value 2 in the second list, at year names at A.
Exactly. So the system now has the number 2 to work with. Maybe it affects program requirements or scoring, whatever. It translates the human-friendly choice into machine-usable data.
That is incredibly useful. It lets the AI act internally based on a simple user click.
Yeah. Think about customer service. User picks urgent from a radio list at Mapo. Could instantly turn that into priority score 5 behind the scenes.
Which could trigger alerts or change routing.
Right. Seamless translation of intent into action.
And thinking bigger picture, like for assessments or decision systems, this has some really important benefits for reliability, doesn't it?
Oh, absolutely. Huge implications. First, validity. The options you provide must target the specific thing you're trying to measure or assess. No random choices.
Like this.
Then, reliability. You get really high inter-rater reliability. Why? Because the scoring is perfectly automated?
No human judgment needed.
None. Zero subjectivity. The choice maps directly to a value or a correct, incorrect status. This builds fairness and transparency into the system. You know, the AI isn't just interpreting fuzzily, it's acting on precise input.
And what about the distractor quality point for assessments? The wrong answers matter too.
Very much so. They need to be plausible. Good distractors help you distinguish between students who truly understand the material and those who are just guessing.
If the wrong answers are obviously silly, the question isn't really testing much.
Exactly. And finally, just showing all the options up front with at radio reduces that cognitive load. The user can focus on the question, not on trying to remember or guess possible answers.
So at radio isn't just a button. It's a carefully designed tool for reliable, clear, single-choice input.
A foundational piece, yeah. Especially within the CAFA protocol.
Okay, so at radio nails it for small lists where you need one unambiguous choice. But you hinted at it, what if you have tons of options? Like choosing your country from a list of 200, radio buttons would be crazy.
Absolutely unusable, and that's exactly where the second tool, at select, shines.
The drop-down menu.
Right, its core function is to create a drop-down menu, and just like at radio,
Yeah.
at Rook, it's designed for situations where the user must choose only one option.
But the key difference is the interface.
Exactly. The design consideration is use at select when you have a long list of options. Why? Because it keeps the interface clean. It avoids that massive, cluttered screen full of radio buttons that would just overwhelm the user.
50 radio buttons for U.S. states. Nightmare. A drop-down. Much cleaner.
Much cleaner.
Keeps things tidy.
And the command structure, the syntax, is it similar?
Pleasantly, yes. It's identical in structure, actually, for consistency. At select variable, label, options list. At it, same components.
Yeah.
Variables for the choice, label for the instruction, options list for the choices.
Exactly the same roles. Makes it easier for people building these interactions using CAFA protocol.
So an example might be at select S1, select AI agent, at agent title, at dead. That creates a drop-down labeled select AI agent, and the options are pulled from some predefined list called at agent title, at dead.
Correct. Or a simpler one, like at select S2, choose a size, small, medium, large. At det would just give you those 3 size options in a dropdown.
Okay. And why is this considered a cornerstone of the dynamic agent model? That sounds important.
It is important because it provides a clean, simple, and error-proof way for users to choose a single specific function or parameter from a potentially long list. Imagine an AI that can perform many different tasks. At select lets you present all those tasks neatly.
So it helps the AI adapt what it offers.
Yeah, it's vital for that. It allows the AI to dynamically present relevant options without cluttering everything up. It guides the user effectively while keeping the interface streamlined, tailored interaction, basically.
Excellent. Okay, so we've got single, unambiguous choices covered, whether the list is short at radio at or long at select at. But what about when you want the user to pick multiple things, like check all that apply?
Ah, yes. The classic select all that apply. That brings us neatly to our third precision tool, at CHECKBOX.
And this one's different.
Yes, this is where it differs significantly from the other two. At select and at radio are for single choices only. At CHECKBOX. At CHECKBOX is designed specifically for situations where multiple selections are allowed and expected.
Okay, so its job is to create a list of checkboxes.
Right. And users can select any number of options from the list. They can pick 0, 1, some, or all of them. Total flexibility in selection quantity.
Perfect for that pizza topping example or choosing multiple interests for a newsfeed.
Exactly. The guidance is clear. Use at checkbox for select all that apply types of questions.
And conversely.
You would not use a checkbox at when the user must make a single exclusive choice. Stick with at radio or at select for those.
Got it. And the syntax. Please tell me it's consistent.
It is. Same structure again. At checkbox, variable, label, options list, embed.
Phew. Okay, so an example. At checkbox C1, select topics of interest, technology, science, art, history. At check-click.
That would show the label select topics of interest and then a list. Technology, science, art, history, each with the little square checkbox next to it. User can tick whichever ones they like.
Okay, now here's the tricky part maybe. How does the system handle getting multiple values back? If I check technology and history, what gets stored?
Good question. This is where it's really different. The variable C1 in your example stores all the selected values together, but as a single pipe-separated string.
Ah, so it would store technology history.
Exactly that string. And when you need to retrieve what the user selected, you'd use at checkbox C1 at check, and that's the value you'd get back.
And then you can work with that pipe-separated list for scoring, maybe? Like in a quiz where multiple answers are correct and the order doesn't matter?
Absolutely. You can use another command, at equal, at eel, to handle that kind of scoring. It's quite powerful.
How would that look? Let's say the right answers for an animal quiz question were rabbit and cat.
Okay. So maybe you define the correct answer set first. At set, answers rabbit, cat, at eel.
Right.
And the user saw a checkbox list, like at checkbox Q1, select all mammals, fish, rabbit, snake, cat, at heel, and they checked rabbit and cat. So at checkbox Q1 at now holds rabbit, cat, or maybe cat, rabbit.
The order might vary depending on when they clicked.
Exactly. So your scoring logic could be at equal, at checkbox Q1, at leal, at answers, at no, at eel.
So what does that no do?
The end no option tells at equal that the order of items in the strings does not matter, so it will compare the contents, ignoring the sequence. Cat rabbit will correctly match rabbit cat.
It's incredibly flexible, perfect for situations where you just care what was selected, not when or in what order.
Precisely.
Yeah.
It handles those multi-select validation scenarios really well.
And thinking about assessments, again, from a psychometric view, using a checkbox seems to allow for more nuanced and challenging questions. Right? It sounds like it tests understanding more deeply.
It absolutely can, yes. And there are a few reasons why. First, there's reduced guessing. It's much harder to randomly guess the correct combination of answers than just one right answer out of 4.
Lower odds.
Much lower. Second, it assesses depth of knowledge better. The user has to evaluate every option independently. Is this one correct? Is this one correct? That tests higher order thinking skills more effectively than just picking the single best fit.
You can't just recognize one right answer. You have to evaluate all of them.
Exactly. Third, the person designing the assessment, the modeler, can precisely control the difficulty. They can adjust how many correct options there are, how plausible the distractors are, more fine-grained control.
And finally,
It provides potentially detailed diagnostic information. If a user checks some correct boxes but also some incorrect ones, The system gets specific data about their potential misconceptions. It knows where the understanding might be breaking down.
Which is valuable for feedback, for learning, or for refining the system itself.
Immensely valuable. So a checkbox isn't just about letting users pick multiple things. It's about enabling a deeper, more precise interaction and understanding when needed.
Okay, this is fascinating. We've looked at these three powerful commands at radio, at select, at checkbox individually. How do they all fit together in the bigger picture? You mentioned multi-input agents as an extension of something called the STAR model.
Right, that's the connection to the broader architecture. The STAR model was an earlier approach. Think of it as single-turn agent runner.
Single turn.
Yeah. The idea was basically you had to give the AI everything it needed in one single prompt. Your entire request, all context, all parameters in one go.
Like trying to order a really complex custom coffee in one breath.
Exactly. And while it worked sometimes, it often struggled because it put the entire burden on the user to formulate a perfect, comprehensive prompt upfront.
That sounds difficult and frustrating.
It often led to this frustrating cycle of trial and error. You'd type your big prompt, the AI would give a generic or slightly off answer, you'd tweak the prompt, try again, back and forth. High pressure, single turn.
Okay, so multi-input agents fix this. How?
They offer two huge advantages, specificity and control. Instead of one giant prompt, the multi-input approach breaks the request into discrete, manageable steps.
Using these commands we've been talking about.
Precisely. You use at radio to ask for, say, the difficulty level, then maybe at select for the subject, then at checkbox for specific features or formats. Each step gathers one piece of information clearly.
So the final prompt that actually goes to the LLM
Is perfectly structured. It's built piece by piece from the user's specific validated choices. This makes the AI's response much more reliable, much more relevant, much more accurate.
It transforms the interaction. It's not just one shot in the dark.
No, it becomes a guided, multi-turn conversation. The AI agent itself intelligently prompts the user for the needed information step by step before it tries to generate the final output.
Like a helpful assistant asking clarifying questions before starting the work.
Exactly like that. A much more natural and effective way to interact, especially for complex tasks.
Can we walk through an example, maybe that quiz generator idea from the notes? How would that look using these commands in a multi-input setup?
Yeah, absolutely. Let's imagine the configuration file, the sort of blueprint for this quiz generator agent.
Okay.
First, you'd likely have an options object. This sets up the agent's basic info. It might have a title like quiz generator, a description explaining what it does, maybe a greeting like, "Hi, let's create a quiz. I need a few details."
Standard stuff.
Right. But the really important part here is the param section inside options. This is the agent's library of choices.
This is where we define the lists.
Exactly. You'd define things like difficulty levels, easy, medium, hard, quiz subjects, history, science, literature, mathematics, and item formats, multiple choice, true, false, fill in the blank, maybe others. These are the predefined lists our commands will use later.
Got it. The agent's ingredients.
You could call them that. Then comes the prompts array. This is the script for the conversation. It defines each turn, each step the agent takes to gather information.
So, step one.
Step one, the agent needs the difficulty. The prompt might be at radio, R1, first, select a difficulty level, at difficulty levels that way.
At right. Okay, so it displays first selected difficulty level with easy, medium, hard radio buttons, pulling those options from the difficulty levels parameter we defined. The user clicks one, say medium, and that gets stored in R1.
Perfect. Then, step two, get the subject. The prompt could be at select S1, great. Now select a primary subject for your quiz, SI at quiz subjects at Hefty, at back.
So that says, great, now select a primary subject and shows a drop-down list pulled from quiz subjects. User picks one, maybe science, which gets stored in S1.
You got it. Then, step three, choose the question formats. The prompt. At checkbox, C1, select the desired question formats to include at item formats at item B.
And this shows select the desired question formats with checkboxes for multiple choice, true, false, etc., drawn from item formats. The user can tick multiple boxes, maybe multiple choice and true, false. That string, multiple choice, true, false, gets stored in C1.
Exactly. Now, the crucial part. Step 4 is the final generation. The agent doesn't ask the user anything else.
It has all the pieces it needs.
Right. Now it assembles the final, complete prompt to send to the actual LLM. This usually involves combining a general system instruction.
Like setting the AI's role.
Yeah, maybe. You are an expert quiz creator. Make the quiz 10 questions long,
Yeah.
something like that. And combines it with a dynamic user prompt.
And this user prompt uses the variables we stored.
Precisely. It might look something like this template. Create a quiz with the following specifications. And difficulty at radio R1, at select S1, at select S1, at checkbox C1, at checkbox C1, at...
So the system replaces at radio R1 with medium, at select S1 at with science, and at checkbox C1 with multiple choice true false.
Exactly. The LLM receives a perfectly structured, unambiguous request. Create a 10-question quiz with the following specifications. Difficulty, medium, subject, science, question formats, multiple choice true false.
And the quiz it generates should precisely match those requirements.
That's the goal, and it's far more likely to achieve it with this structured input than with a vague initial prompt like, make me a medium science quiz with some MC and TF questions. This is the power of CAFA, predictable, reliable results through structured interaction.
Wow. Okay, so there we have it. We started this deep dive wondering about that gap between how we talk and how computers, especially AI, need information structured. And we've really uncovered some elegant solutions here using the CAFA protocol and these specific symbolic commands.
Yeah, it's quite neat, isn't it? We saw how at radio, that gives you that forced single choice from a short list. Very clear.
Right. And at select handles the same single choice, but cleanly, from a much longer list using a dropdown.
Keeps the interface tidy, and then at checkbox, at XFAR, gives you the flexibility for multiple selections when that's what's needed.
And these aren't just like interface widgets, they're actually tools for precision.
Exactly. Precision tools for creating predictable, reliable interactions. They translate what can be fuzzy human intent into clear, actionable, structured data that the AI can actually work with effectively.
So maybe a final thought for everyone listening to chew on. How does this shift from just throwing a prompt at an AI and hoping to this more structured, multi-turn conversation? How does that change things? Not just making AI more reliable, but maybe changing how we even think about talking to these systems.
That's a great question. Does it make us more precise in our own thinking when we have to break things down step by step?
Yeah. And what other kinds of complex interactions, beyond just quizzes or forms, could really benefit from this kind of guided, controlled approach? Imagine using this to guide an AI through, I don't know, designing something complex, or maybe even helping with a tricky diagnosis, step by step, making sure every key piece of info is captured perfectly.
The potential is huge. It really shifts the dynamic from hoping for understanding to ensuring it through clarity, building trust, really.
Well, this has been incredibly insightful. Thanks for diving deep with us today.
My pleasure.
We'll get you on the next deep dive.